Okay, our last speaker is Maxime Payard, and this is going to be a talk on summarization. We had a joint generation and summarization area this year, so we're splitting the two. Take it away.
So hi everyone, I'm going to talk about summarization and extractive summarization, and especially the evaluation of summarization. So just briefly, in extractive summarization, we consider the input as a set of sentences, and a summary is simply a subset of these sentences. Therefore, a summarizer is a set function which takes as input some documents and outputs the summary. And the question we want to ask is how can we evaluate this summarizer, and especially how can we use human judgments to evaluate this summarizer. So before starting, we'll go with some terminology. And extractive summarization can be thought as the combinatorial problem of selecting sentences, or a set of sentences, and it can be split into two different components, independent components. So the first component will be what we call the objective function, which is a function that takes the input and the summary and measures how good it is, how good is this summary. This function encodes the assumptions that the summarizer or the assumptions that are made about what makes a summary good. And the second component will be the optimizer, which is the way to extract the set of sentences that maximize the previously defined objective function. So it takes as input the input and the objective function and outputs the actual summary. So this is actually solving the argmax problem on the objective function. So it is quite clear that whenever we have a pair of an objective function, we call theta, and an optimizer, we call O, this is clear that this gives us a summarizer, but it is also true that for every summarizer, there exists at least one pair of an objective function and an optimizer, which is equivalent. By equivalent, it means that it extracts exactly the same summaries for the same input. So it really means that every summarizer has implicitly or explicitly an objective function that is maximizing. So if it's not a purely random summarizer, then it extracts the summary for some reason, and these reasons are encoded by what we call the objective function. So just to fix some ideas, we can give some examples. So there's this XC system that is quite simple and quite strong, which maximizes the number of frequent concepts, or bigrams in the case, with an integer linear programming. There's also, for example, the lex rank system, which maximizes the sum of the page rank scores of sentences greedily. And last year also we presented a summarizer that minimizes the Jensen-Shannon divergence between summary and document with some meta-heuristic optimizers. And there are many other examples that we provide in the paper. Now we can come back to the question of evaluation. So what we want is to measure the quality and the robustness of summarizer, especially of the content selection that they're doing when we think about extractive summarization. And by that we mean somehow what is the agreement that the summarizer is having with the human. So what we do currently, what is the common standard, is that we use and develop evaluation functions which are very similar to objective function because they say also how good is this summary. The only difference, which is important, is that the evaluation function has access to reference summaries or other human annotations in order to make these judgments. And the typical example of an evaluation function would be this rouge metric that we use that is quite standard in summarization. But when we do evaluation with such evaluation function, we have to accept that this is a surrogate for human judgments, and it can be rather poor sometimes. And we also only evaluate the single summary that has been extracted. It means we do not evaluate the whole summarizer. By that I mean its strategy, or its assumption that it's making about the summarization task, or why does it extract these precise summaries. So we propose a complementary evaluation, which is quite simple and and like different but complementary. So instead, we propose to evaluate directly the objective function against the human judgments, so without considering only the chosen summary after optimization, so only the objective function. And so it's asking the question whether the objective function or the assumptions that are made by the summarizer correlate well with the humans, and does it make sense to optimize for this function in the first place? So can this summarizer model what humans believe about summarization? So to do so, we use these human judgment datasets that have been created during the duck and tap share task, for example, but we could create more in the future. And for these datasets is that for each topic, there are several summaries that have been scored by humans. So each topic that have been summaries that have been scored by humans. So for example, here in the first summaries, humans believe that it was a good one. The second, humans believe that it's very bad, and the third that it was average. And then we score these exact same summaries with the objective function of summarizers. So for example, the summarizer A believes that the first summary is very bad and the second is good, and summarizer B believes the first one is average and the second is very good. And then we can simply compute the correlation between these human scores and the objective function scores for each summarizer, and compare the scores across summarizers. So we go from some initial experiments. So we use the TAC 2008-2009 share task for this, and we identified some objective function of common summarizers, and we use the annotations provided by humans for both pyramid and responsiveness. So pyramid measures content selection, and responsiveness is more about the general quality of the summarizer, not only the content, but also some readability or coherence. We also use different correlation measures, because when we compute the score of the correlation between the objective function and the humans, it depends what we are interested in. So for example, if we compute persons R, it means that we look for value correlation, which depicts linear relationships between the scores of the humans and the score of the objective function. And the Spearman's rho is a rank correlation, which means that we are measuring how well the summarizer is ranking the summary according to the human one. And maybe the most interesting one would be the NDCG, which focuses on the top element. And we can really expect that summarization systems that have a high NDCG will extract good summaries after optimization, if the optimization is good enough. So there's a lot of experiments that we detail in the paper, but the main observation that we can say is that the correlations are quite low. So they're around 0.5, which means that the summarizer that we investigated do not model very well the human's opinion. Some of them can extract decent summary because they have a correct NDCG, but it's still quite low, which is quite interesting. It means that we could work more in this direction and focus on this direction to get some further insights on the task of summarization, like modeling the human opinion. Also, it is a different ranking of system than when we use the evaluation of summary at the end. So, and also some summarization systems which are quite old, like the Edmondson one, were among the best in our evaluation. So they have somehow, Edmondson is based on few phrases and similarity with titles and these kind of features, and they were quite good objective functions in our experiments. So I'd like to finish with some discussions about this way of evaluating summarizer, which will be complementary to the other one, the traditional one. So with this evaluation, we focus on an important assumption of summarization. So what makes a summary good, and that's what we want to evaluate. And we can do this directly against human judgments. We don't need to use the surrogate function like rouge or different variants of rouge. There is also no side effects from the optimization. So when a summary is extracted, we don't know whether the objective function was very good and the optimization was bad, or whether bad optimization technique with a bad objective function can also give some decent summary with some side effects during the optimization. And we also don't need human summaries for this. But on the other hand, we need annotated summaries. So these are available in some shell tasks, but we would probably need to create more if you want to go with this evaluation. And for some summarizers, it might be difficult to identify actually the objective function. So for most of them, it's quite straightforward, but for some of them, it might be difficult. And we also focus on a task which is a bit harder than the task of summarization, where we just need to extract one good summary. Here we want to also model the human opinion about summarization. That's it for me. Thank you.
Hi, we work on summary for a while, so I think I missed something. So if you have human evaluators, why don't you just take the human scores of objective functions themselves? Just use the human labels as objective function.
Yeah. So when we make a summarizer, we cannot have access to human judgment.
But you have that, right? You can do that on training data, right?
Yeah, of course.
Then you just. Yeah. So the purpose of your work is not to optimize on summarizing performance, but to evaluate other people's summarizers?
Yeah, that's one way of evaluating objective functions, and of course it leads to the thing that now we should create system by weekend, and the next step would be to develop a system which create an objective function that learns the human judgment.
Yeah, but I'm not convinced that you should evaluate objective functions. You really should look at the final summaries. Well, I'm just not convinced because I know your arguments it's better that way. To me, it's the opposite. You know, you want to look when you work on a task, you want to evaluate the final product, the final output, right? I'm not convinced that evaluating objective function really is the good evaluation matrix.
So
I mean, Rouge is not perfect, but it gives us something.
So it's not.
So when you say the benefits is you don't need human summaries, a human evaluator, and all that. To me, that is not a benefit. That is a problem.
No, I think, so for me, I have a different opinion, but the thing is that here when we focus on this task of objective function, it's a complementary task to the traditional one, I would say, because in the traditional one there will be these side effects coming from the optimization, and we extract this summary, but we don't really know why. We could have a summarizer that gets this summary, but do not model human judgment. So I agree that the end goal is to get good summaries, but to get there it would be, I think, interesting to evaluate
so it's the intermediate evaluation.
Function. Yeah.
Yeah.
So we have these two independent components, and we could evaluate them independently. If we develop the perfect objective function, then we really just need to optimize this function to get the summarizer.
I'm not.
Yeah, actually I think I agree with Pascal, but I wanted to, this reminds me a bit of the kind of P versus NP kind of notion of like, well, if P equals NP, then a critic could make a really good movie. And I feel like that's what you're claiming here, that like, if only we could pose these objectives that we know are going to be hard and we can't optimize, then that would really help us in summary. Yeah. But we know that's not the case because we can't optimize them because they're really hard.
So I think we can optimize them. So, for example, so not exactly, but really. But then there are two different research questions, I would say. First, can we model the human assumption about summarization? And then can we optimize? If we find a very good one, can we optimize it? And if it's very difficult to optimize, then we can look for linear approximation or for some relaxation that we can optimize. But that would be, I would say, a different research question. So two connected, but
I guess we should propose, I would propose we proceed kind of breadth first down that as opposed to kind of doing one at a time. Yeah.
Thanks for the presentation. One quick question. That you constrained your work in the extractive summarization part, but what if I want to evaluate the abstractive summarization system?
So I think you would need to develop, already you need to have some of the data sets, because here we focused on extractive summarization because the data was available and it was simple. But then you would have to think also a bit about what would be the objective function in the case of an abstractive summarizer. So you need to take into account a lot about readability, coherence, and grammaticality of this kind of thing. Which here we focused on your importance selection, because it's easier as a first step. When you want to go for abstractive summarization, you will need to include all of these.
Goodbye.